Okay, so I know we've got our quiz coming up tomorrow, and I wanted to make a quick video going over a few additional things that we might not have had a chance to actually go through together in class. So we've done assignment 1 together. That's been submitted. We worked on 1 and 2 in class, and then number 3, I made the video last time going over number 3. And so you have that available to you as well. If you're confused on any of these drop problems, I'd encourage you to check those out because 2 and 3 were some of our first couple drop problems. Number 4, we did together in class, and then it was also part of the homework, so I wanted to make sure that we are good to go there. If you've got questions on it, please don't ever hesitate to ask, but we did go over that and get ourselves our 2.4. Remember, the answers are also provided at the end of the problem, or at the end of the packet for each one of these individual assignments. You didn't have to do the remainder of number 1, so don't worry about it. And then there are the answers for 4 through 8 that we were looking for. And then assignment number 2. So I know assignment number 3 is your homework. I asked you guys to do your homework for tonight. I asked you guys to do 1, 3, 4, and 6. You didn't have to do 5. I hate the way number 2 is worded, so I'll never phrase another one that way again. But I wanted to take a moment and actually go over assignment number 2 so that you get, I guess, additional practice or have an additional resource to help you prep for this quiz that we've got coming up tomorrow. That's what the point behind this is meant to be. So with assignment number 2, I'm going to go through each one of them individually, walk you through why I picked the equation that I did, how we should set it up. That way, when you try this yourself, because remember, one of the best study tips I've ever been able to give anyone, and I wish I didn't wait until I was 22 years old, my last semester of college, to learn this, was put everything away and treat a homework assignment like it was the quiz. See what you can do, pull out the answer key that we've gone over, look through that again. And then, compare basically what you did on your own to what we had already talked about in class. And if you don't have things matching up or are still confused, that is a great source of questions that you can ask, right? It's a lot better than just saying, hey, I don't understand number 5. Can you do all of number 5? I totally will, but if I know exactly what your question or concern was, then I won't waste time identifying with number 5, hey, meters per second means speed. That way, if you knew that already, we don't have to rehash that. So that's the objective, I should say, behind this particular video. So we're going to start with number 1. And like always, I'm going to make my list of variables that we start with. So first thing I read as I'm going through number 1 is a car at rest begins to accelerate. So the first thing I can write down, the first thing that I know is that my initial velocity is 0 meters per second. It begins at rest, so there is no initial speed. Then they give me an acceleration. It's an acceleration of 2 meters per second squared. A lot of folks will look at that meters per second squared and think, oh, meters per second is a speed. This is not your final speed. This is a rate of acceleration. How fast will the car be moving? So that is your other indication that you shouldn't have had that labeled as your velocity, that 2 meters per second squared at least. So this is your final velocity is what you're solving for, and then they give you a time. The time they provide you is 20 seconds. So what equation am I going to pick from this list? The first thing I think of is, remember that chart that I had up on the board with all of your variables, the symbols we use for those variables, and what units they're measured in? You'll notice one of my 5 variables in this unit is missing. The variable that is missing and not mentioned is distance. That's not to say that we can't use distance. All I'm saying is distance wasn't included, distance wasn't asked for. I'm going to pick the one equation, ideally, that solves for final velocity that does not contain the letter D anywhere in there. And that equation is VF equals VI plus AT. That's my equation. Final velocity is what I'm solving for. 0 was my initial velocity, my initial speed. 2 is my acceleration, and my time was 20. So while you might have accidentally multiplied these two together, if you didn't do any of these steps leading up to this, you won't always get lucky in that regard. One of these could have been squared like time is in our 4th equation, or like both of our velocities are in our 3rd equation. The relationship between acceleration and time might have been that you divide them. So you need to make sure that you know why you're doing this. And so that's why this is what I want to see. From here, your final velocity very naturally is just going to be 40 meters per second. This is what I expect to see on the written portion of the exam, right? That's why I kind of walk through it that way every single time. So that was number 1. Number 2 is the next one I'm going to try. So with number 2, we have a roller coaster with a velocity at the top of a hill at 10 meters per second. One of my velocities is 10 meters per second. I don't know yet if this is my final velocity or my initial velocity, so I'm going to keep reading. 2 seconds later, a couple things there. Time obviously is 2 seconds, and that also tells me that 10 is my initial velocity because 2 seconds later, I'm probably doing something different. I reach the bottom of the hill with a velocity of 26 meters per second, so my final velocity is 26 meters per second. What is the acceleration of the coaster? Acceleration is what we're solving for. I already know what the units of my acceleration are going to be. It's the units of our velocity divided by the units of my time, meters per second, or meters per second squared, naturally. Again, nothing is written about or asked about distance in any way, shape, or form, so I'm probably going to use the same equation I did last time. I am using that same equation. I am just going to use the other version of that equation, the one that is rearranged to solve for acceleration. Notice I did the derivation in class to show you that the equation from 1 and the equation from 2 are the same equation. They're just rearranged to solve for something different. And you can do that algebraically anytime you want. So in this particular case, plug in what you've got. Acceleration is 26. Subtract 10 from that and then divide by 2. So while you don't need to show all of the work, this, what I'm going to show you here, is at minimum what I should see. 26 minus or subtracting 10 from 26 will give you 16. 16 divided by 2 is 8. 8 meters per second squared is your final answer. And that's really all I need to be able to see for number 2. I'm going to keep it moving because this isn't meant to be like super instructional. Like this is just our work. This is what we should be able to do for each one of these problems. So if you've got questions, concerns, please never hesitate to message me with an email or through Teams. A roller coaster is moving at 25 meters per second. Meters per second describe a velocity. Always. It's not an acceleration. It's a velocity. As the ride ends, 3 seconds later, so it comes to a complete stop. So 25 was my initial velocity. Final velocity is 0 meters per second. That is what it means to be stopped. That took 3 seconds to get there. Cool. What is the roller coaster's acceleration? Same exact problem as before. What I added to this one, what makes it different and unique, is that instead of starting at rest, like problem number 1 did, or having 2 velocities in number 2 that were non-zero, here I use the phrase comes to a complete stop. That told me my final velocity is 0, and I can use the exact same equation that I had done before. I've got my final velocity minus my initial velocity divided by my time. In this particular case, I've got a final velocity of 0 divided by a time. Did I give myself a time? Oh, I did. 3 seconds. Why did I write that as a question mark? Silly, silly, silly. Okay, cool. Mr. Willis would have lost half a point for being weird. Not the first time. So there's my 3 seconds. So in this particular problem, there is something that's going to be really, really, really important. You have to remember that that negative needs to remain with that 25. Yes, we're subtracting 0 or 25 from 0, but our acceleration here needs to be negative. We're coming to a stop. It means deceleration, or in physics, instead of saying decelerate, we just say negative acceleration. So negative 25 divided by 3 is going to give me a negative 8.3 meters per second squared. That negative, again, not a bad thing like it would be if you saw a negative in your bank account. All it means is that you're losing 8.3 meters per second every second. So that was number 3. Number 4. In number 4, a car at rest. Initial velocity is 0 meters per second. Now I'm going to keep reading. A car at rest accelerates to 24 meters per second. That's another velocity, and because I already knew my initial velocity was 0, this is my final velocity. Over 34 meters, this is not a time, this is a distance. 34 meters is the distance that it does that acceleration over. I'm looking for A. It's probably going to be measured in meters per second squared, and time is the one thing that is not mentioned anywhere at all. There's only one equation on your equation packet that does not contain the letter t, and it is VF squared equals VI squared plus 2AD. I'm not saying you can't solve for time and then use that time to get your acceleration. I'm just saying, why give yourself the extra step? This equation works perfectly. Yeah, you got to square some stuff, but that should be pretty straightforward for us now at the level of mathematics that we've had. So we've got 24 squared is equal to 0 squared plus 2 multiplied by a, don't know what that is, multiplied by, let me scroll over a little bit more, I'm starting to run out of space, multiplied by 34. So 24 squared is going to give me 576. This is going to be equal to, obviously, that whole 0 squared thing I can get rid of. 2 multiplied by 34 is 68 multiplied by a, because that is my acceleration. All I did was simplify that a little bit. Divide both sides by your 68. So divide by 68, and we get an acceleration of 8.47 meters per second squared. There she is. Don't forget your units at the end of your problems. But that was number 4. So let's continue on. Talk about 5 and 6. So for number 5, a car moving at 43 meters per second. We have a velocity of 43 meters per second. I don't know if this is my initial or final yet, so I'm going to keep reading. Comes to a complete stop. Okay, well, that answers that. My final velocity is 0 meters per second because it came to a stop. That means 43 has to be the initial speed it had before coming to a complete stop. It does so over a distance of 102 meters. And I want to calculate the car's acceleration again. Notice, same problem as last time. So if number 4 was tricky for you, here's your chance at redemption. That's really all this was meant to be. So from here, we've got, again, VF squared is equal to VI squared plus 2AD. Let me get rid of that because this is meant to be an equal sign, not a not equal sign or inequality. So let's see. 0 is now my final velocity. Makes things a little bit different, and that's why I included this problem. We have 43 being squared plus 2 multiplied by a multiplied by 102. So one of the things we have to do first, and I'm going to go step by step here because the algebra might get a little tricky for some of us, and that's fine. We have to get acceleration by itself, and you do your reverse order of operations. Anything being added to this term, 2a102, needs to be dealt with first. So 43 squared, not something I can do in my head, 1849. You wind up with 0 equals 1849 plus, I'm going to simplify what I see over there, 204 multiplied by a. You should now subtract from both sides 1849 because it was being added to your term containing your unknown. You get 204 multiplied by your acceleration on the right left over. That negative is very important. Again, you came to a stop. You need to have a negative acceleration. Divide both sides by 204, and you're going to get yourself negative 9.1, basically. I rounded a little bit, but negative 9.1 meters per second squared. That negative, again, crucial, came to a stop. That was it for number 5. Number 6, we've got another drop problem here. So a rock is dropped. Number 6, the word drop tells me 2 things. First, tells me my initial velocity is 0. Second, tells me my acceleration is 10 meters per second squared. Those are the 2 things I know right off the bat because I saw the word drop in my problem. The next piece of information that is provided, they give me a distance of 28 meters, and they ask me how long it would take to reach the water down below. That's probably going to be measured in seconds. And the one variable, just like we mentioned in class, that is not provided is a final velocity. It's not there at all. And because final velocity is not provided, there is only one equation that we can use, and that one equation is distance is equal to your initial velocity multiplied by time plus 1/2 of the acceleration multiplied by time squared. That's the only equation we can use. Let's plug in what we know. 28 is equal to, this whole term goes to 0. You do not need to include it because your initial velocity was 0 as well. So we get 1/2 of 10 multiplied by t squared. This is going to wind up being 28 divided by 5, essentially. 28 divided by 5 gives me 5.6 is equal to t squared. Take the square root of both sides. So second square root, that previous answer, we get 2.36. So let's just round it to 2.4. And your unit is seconds. There she is. So if after looking over all of these 6 problems, we are confused, we are hesitant, we are concerned that we don't know what we're doing, I would encourage you to print an additional copy of Assignment 1, Assignment 2, or Assignment 3, any of those. Try the problems I assigned. Don't try something I didn't assign because they won't be on the quiz, but try some of those problems that I have assigned. And if you've got questions or concerns after trying them a second time, reconsulting this video or any of the answer keys that I provided you, then please, 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 please do not hesitate to reach out and ask whatever questions it is that you might have. Your quiz for tomorrow is going to be on Quiz-Is, as the calendar states. So make sure that you're giving that a shot. It'll be available until about midnight, 11:45 p.m. It's the latest it'll let me set something to close. So you have until then. You get one shot. Please make sure we know what we're doing ahead of time. Message me with questions, please.